Hello everyone, my name is Vinicius Mandela. I am a student of Chemistry Study Program, Faculty of Science and Engineering, Louisiana University. So for my English final exams, I'm gonna tell you about the development of atomic theory. So first, I'm gonna tell you about atom. Atom is a smallest unit of ordinary matter that form a chemical elements. Solid, liquid, gas, and plasma are composed by a neutral or ionized atom. Atoms are very small, around 100 picometers across. Atoms were first discovered by two Greeks, namely Leucippus and Democritus, around 450 before Christ. They said that all the matter is composed by a very small and indivisible particles called atoms. So atom is from Greek that namely atomos, that means not divided. The development of atomic theory was carried out to perfect the previous theory. In 18th, several discoveries related to the new atomic theory began to be made. The first person start to development of atomic theory was John Dalton in 1803. The emergence of the Dalton's atomic theory aroused curiosity related to the study of various types of atoms. The contents of John Dalton's atomic theory are as follows. 1. All atoms are the smallest part of an element and can be further divided. Similar atoms have the same properties, while other atoms with the dissimilar element have a different properties. In a chemical reaction, atoms combine or separate. Atoms can be combined with other atoms to form molecules in spherical and simple ratio. In practice, Dalton's theory has several drawbacks, including it can describe how atoms combine. Atoms of one element with atoms of other elements can't be described. The relationship between the composed solution and the electrical conductivity cannot be described. The electrical properties of matter can be described. After the Dalton's atomic theory, the next figure in the development of atomic theory is Thomson's atomic theory. In its development, Thomson corrected the deficiencies that exist in Dalton's previous atomic theory. In 1897, Thomson discovered a negatively charged particle called the electron. The electron is a discovery that aims to correct the shortcomings of the previous atomic theory. Thomson's atomic theory began with the discovery of the cathode tube by William Crookes. From the research that Crookes had done, Thomson developed his research on cathode rays at the Cavendish laboratory. After finishing and results of his research, Thomson discovers that cathode rays were particles. This is because the cathode rays are able to rotate the fans that are placed between the cathode and anode. After knowing this, Thomson stated that cathode rays belong to the particles that make up atoms or subatomic particles, which have a negative charge and are now called electrons. These negatively charged particles or electrons will contain the contents of Thomson's atomic theory. The content of Thomson's atomic theory is positively charged sphere containing several negatively charged or electrons. These electrons will be scattered on the ball like raisins on bread. Thomson's atomic theory can be called the raisin bread theory. named the theory of resin breed because of the negative charge or electrons rising or surround positively charged atoms that breed. Just like Dalton's atomic theory, Thomson's atomic theory also has shortcomings. They are Thomson's atomic theory can could not explain how the arrangement of the positive charge and the number of electrons in the sphere. The atomic nucleus cannot be explained. The next atomic theory is the theory of Ernest Rutherford and his two assistants. Ernest Rutherford and his two assistants discovered the atomic nucleus in 1910. The atomic nucleus has a smaller radius than its atomic radius. Rutherford's theory came from the experiment of bombarding the nucleus of a gold plate with alpha particles. A particle with a mass 4 times the mass of a hydrogen atom and a positive charge twice the charge of an electron. This experiment is called the Geiger-Marsden. The name of this experiment was taken from two of Rutherford's students named Hans Geiger and Ernest Marsden. While conducting the experiment, Rutherford devised an experimental design for bombarding gold atoms with alpha particles emitted by radioactive elements. After being emitted, the result is that radioactivity is reflected, transmitted, and deflected. From the result of the experiments carried out, Rutherford hoped that all the alpha particles will pass straight through the gold plate. However, this expectation does not match the reality, so that the fact obtained is that there are alpha particles that are deflected between 900 or 18,000. Based on the result of the experiment conduct, Rutherford concluded that if an atomic nucleus is hit by an alpha particle, a collision will occur which causes a deflection or reflection of the alpha particle. The reason for this is that the mass and the charge of the atom are concentrated in the nucleus. Thus, Rutherford argued that the charge on the atomic nucleus is equal to the atomic mass in atomic mass units, or MU. From the result of this experiment, it can be ascertained that Rutherford's atomic theory invalidates Thomson's atomic theory. The thing that caused the fall of Thomson's atomic theory was that Rutherford discovered the atomic nucleus in the atom. This atomic nucleus has a positive charge, which is the center mass, and is surrounded by a cloud of negatively charged electrons, or can be said to be like the shape of the solar system. Although Rutherford's atomic theory has invalidated the idea of Thomson's atomic theory, but Rutherford's theory still has shortcomings. Namely, this atomic theory can describe the rotation of the atomic nucleus and the location of the electrons. This atomic theory can describe the spectrum of lines that exist in the hydrogen atom. Atomic energy becomes unstable because moving electrons emit energy. Niels Bohr is the physicist from Denmark and the Nobel Prize in Physics in 1922. Bohr started research on atoms in 1913, and the name of the result of the research is the spectrum of the hydrogen atom. The shape of Bohr's atomic theory can be said to be like the rotations of the planets around the solar system. Bohr experiments result in electrons orbiting the atomic nucleus consisting of protons and neutrons, and in certain orbits called electron cells or energy levels. After cycling the atomic nucleus, the electron can move from one cell to another by the absorption or emission of certain energies. The essence of Bohr's atomic theory can be summed up into the four nuclei, namely, electrons revolve around atoms in certain orbit. As long as the electron is in the trajectory, the energy of the electron remains constant so that no energy is absorbed or emitted. Electrons can only move from one shell to another by absorbing or emitting energy. The paths that electron allows are those that have an angular moment of an integer multiple of h to p. In practice, Bohr atomic theory has several weaknesses. They are: this atomic theory can explain the spectrum of atoms larger than hydrogen. This atomic theory can explain the Zeeman effect. The reason the theory of quantum mechanics was developed was to revise Bohr atomic theory. The theory of quantum mechanics was perfected by Erwin Schrödinger, an Austrian physicist and winner of the Nobel Prize in Physics in 1933. Development of modern atomic theory based on de Broglie's hypothesis. According to Louis de Broglie, dualism applies to electrons, that is, electrons are not just particles, but also waves. In other words, electron will move like a wave and have path that is also a wave. It was not only Schrödinger who developed the modern atomic theory, but there was a researcher named Werner Heisenberg. Heisenberg and Schrödinger worked together to develop the modern atomic theory. The theory that has been developed by these two researchers is currently the atomic theory of quantum mechanics. If Schrödinger's research is based on the Broglie's hypothesis, then Heisenberg's research is based on Werner Heisenberg's uncertainty principle. From this principle, Heisenberg concluded that there is a limitation in determining the position and the momentums of electrons. The atomic theory of quantum mechanics can be said to be the most recent series of several atomic theories that have been developed. All the matter is composed by a very small indivisible particles called atoms. Every atom is composed by a nucleus and one or more electrons that bounce around the nucleus. More than 99% of mass of an atom is in the nucleus. The nucleus is made of one or more protons and a number of neutrons. The protons have a positive electric charge, while the electrons have a negative electric charge, and then neutrons have no electric charge. Until now, no one has been able to see the atom either directly or using tools such as a microscope. Thus, no one never know the shapes of the atom. So you may be the next people who will discover the new atomic theory. That's all from me. Sorry if there are mistakes, and thank you for watching my video. See ya!